Hey guys, welcome to the Raptors, a digital platform of the RAPT Extend tutorials. Today we are going to discuss inverse trigonometric functions, for which I have made a table here. So this chapter is extremely easy. It is highly scoring. So let us look at the table first. So this table lists the serial number. Here you have functions. So I have noted down all the functions, domain and their range. Let us try to understand what is an inverse trigonometric function. Suppose one is having y is equal to sine theta, or let's say x equal to sine theta. Then theta becomes sine inverse x. Now you see that inverse trigo function tells us about the theta, the angular value of a function. So here we are going to discuss that only. Now this table lists the principal domain and principal rate of the function. In your question, in your board exam, you are mostly asked about the range of the trigonometric function, or you are mostly asked the value of the principal value of the trigonometric function. For example, you see for sine inverse x must lie between -1 and 1, and its range is from minus pi by 2 to pi by 2, that is fourth quadrant and the first quadrant. Let me plot this, let me show you graphically. This may look detailed, but it is extremely easy if you look at on the graph. So I plot a quadrant like a plane in which this is first quadrant, this is second quadrant, third and fourth quadrant. This angle is 0, this is pi by 2, this is pi, this is 3 pi by 2 and 0. So we know that if you move counterclockwise, the angle measurement is positive. If you move clockwise, the angular measurement is negative. Now if one is having three functions, sine inverse x, tan inverse x and cosec inverse x. For these three functions, if one is having positive value of the argument, the angle will the range is this, principal range is this. So for positive value of the argument, the angle should be in the first quadrant. For negative value of the argument, it should be in the fourth quadrant. Let us take an example. Sine inverse of 1 by 2. You see the argument is positive. Now since argument is positive, its value, principal value should be in the first quadrant. So we know the angular value for sine, like if the angular value for which sine theta is half is 30 degrees, so it will be pi by 6. Now if we want to find out sine inverse of minus half, you see argument is negative, that means it should be in the fourth quadrant. So the angular measurement should be just negative of the theta. So for these trigonometric functions, if sine inverse, if the angular measurement is positive, you go to the first quadrant, and then the principal value will be just the positive value of the angle. And if you are in the if the argument is negative, you just have to make the principal value with negative sign. So the angular value will be negative of the what you got for the positive argument. Now for rest of the three trigonometric functions, the principal value is this, 0 to pi. So this is minus pi by 2 to pi by 2. Now here you have 0 to pi. If the angles are positive, argument is positive, you get it in the first quadrant. If it is negative, you go to the second quadrant. For example, if cos inverse half, the argument is positive, you must be in the first quadrant. So the answer should be pi by 3, that is 60 degrees. But if your angular value is, if the argument is negative, that is minus half, then you should get into the second quadrant. Your answer will be pi minus pi by 3, which is 2 pi by 3. So for cos inverse x, cot inverse x and sec inverse x, one should be doing this. That is, for positive value, you stay in the first quadrant. For negative value, what you'll have to do, you'll have to just subtract the value of theta, which you get for the positive value, from pi. That is, you just subtract pi by 3 from pi if the argument is negative. If it is positive, you just put pi. So let me summarize. For sine inverse, tan inverse and cosec inverse, if the argument is positive, you write the principal value, which lies in the first quadrant. If the argument is negative, then you just put negative sign in front of what you have got for the positive argument. Now, for cos, cot and sec inverse, if the argument is positive, you get to the first quadrant, normal principal value. But if it is negative, the only thing that you need to remember is you need to subtract it from pi by 3. That's all. That's you need to do. So that's all we have from inverse trigonometric function, guys. It is extremely easy and highly scoring. Going through matrices and determinants. Matrices, you know that it is arrangement of elements or functions in rows and columns. Now, the types of questions which may asked in your board exam related to matrices and determinants are like this. The tricky question or objective type questions that can be asked is like this. Find determinant of adjoint of matrix A. Now, it will be determinant of A to the power n minus 1. So this is tricky question. It can be asked in your objective section. The other question that can be asked is find determinant of inverse of A. So it will be 1 by determinant of A. The other type of question which can be asked is show a matrix A as sum of symmetric and skew symmetric. So A will be half of A plus A transpose, half of A minus A transpose type. So this type of question, a square matrix will be given to you. You need to express it as sum of transpose and skew trans, like sum of symmetric and skew symmetric. So this part is symmetric and this is skew symmetric. And to remind you what is symmetric matrix, if A transpose equal to A, it is symmetric, and if A transpose equal to minus A, it is skew symmetric. So this is first kind of problem that can be asked. This is second kind of problem that can be asked. The third kind of problem which can be asked is, you'll be given a matrix. Suppose a matrix is given, a square matrix 3 by 3, and a relation will be given like A cube plus 6A square minus 5A plus 3I equal to 0, let's say. You need to show, if A is this, show that this, hence find A inverse. You know, the usual way to find A inverse is to first find minors, cofactors, adjoint, and divide it by its determinant value, and then you get A inverse. But here, you don't have to find all those. Since question says hence find A inverse, that means from this equation you'll have to find A inverse. So what to do in this case? Take 3I on the right hand side and then take A common, or multiply it by A inverse throughout. So you get A square 6A minus 5I equal to minus 3 A inverse. Now you want A inverse, then you need to divide by minus 3. So A inverse will become minus 1 by 3 A square 6A minus 5I. So this is your A inverse. Now, the other type of question which can be asked in your exam is, you'll be given a pair of linear equation like a1x uh, like b1y plus c1z equal to d1, a2x b2y plus c2z is equal to d2, and a3x plus b3y plus c3z equal to d3. Suppose you are given this equation, pair of linear equation. Then your solution, you can express it in form of matrix a1, a2, a3, b1, b2, b3, c1, c2, c3, and here x, y, z, and on the right hand side you'll be having d1, d2, d3. This matrix can be written as ax equal to b. So this matrix is a, that matrix is x, and that is b. So your x will be a inverse b. Now this a inverse b, that means one needs to find a inverse here. Now for this, for finding out this a inverse, you need to find minus. First you need to find determinant of a. If determinant of this matrix is 0, there the solution don't exist. That a inverse don't exist, and then solution don't exist. So if determinant value is non-zero, you proceed with further steps to find a inverse. Now first you need to find minus and then cofactors, and then you need to proceed ahead, find adjoint, inverse, and once you have inverse, multiply it with b, you'll get a column matrix having 3 values if there are 3 variables, and then you can find values of x, y, and z. I recommend you to put those values back here in this equation and verify your answer. These questions will be a 5 marker. So these are the questions which come from matrices and determinant. So we'll meet in the next video. Till then, take care. Bye.